In today's lecture of mobile computing, we are looking forward to the activities which can be sensed using the mobile sensing and the mobile sensors. Let us firstly start one by one with the each activity that can be sensed. Firstly, we'll start with the localization. What localization is? Localization in a cellular communication is the technique of pinpointing the exact region or geographic position of a user or a device. For example, your device is placed at which position in your room that can be mapped or that can be sensed using the localization technique. Localization is done by mobile servers by collecting the unit data of the sensors and then correcting the precise location by various algorithms whereby error is removed by probability. Here, the error should be very minute because if the error is huge or if the error is a bit large, that would not be acceptable in case of localization because that problem is further needed in various other tasks. Localization has been a top concern of various tech analysts who think that the privacy of a user is at risk when localization is performed. This is because whenever the localization is performed, the personalized data or the trajectory or the actions of a user are being sensed at the moment. But while sensing the actions, while sensing the activity of the user, the privacy can be breached. Anyone can predict the further action of the user and thereby can provide any kind of harm to the user. So, arguing that the process requires additional information is also a validity in case of localization. Next kind of activity that we can discuss from the sensing is the motion tracking. As you can see in the diagram, so localization was the location, exact location of the user, but motion tracking may refer to the movement of the user, like in which motion the user is moving to. Motion tracking may refer to motion capture, which is the process of recording the movement of objects or people, and match moving, a cinematic technique that allows the insertion of computer graphics into live action footage with correct position, scale, orientation, and motion relative to the objects in the shot. As you can see in the diagram, the hands are moving in a certain direction, the leg is moving in a certain direction. So, this is a kind of motion tracking technique. The motion tracking technique has its application in variety of areas. Firstly, it is applicable in the military area, entertainment zone, sports activities, medical applications, validity of the computer visions and robotics. Also, motion tracking has been widely used in filmmaking and in video game development for making the robots to move according to the movement, according to the button pressing or the keyboard pressing. In many areas, motion tracking is often called motion capture, whereas in filmmaking and games, motion tracking is commonly called motion moving, matten moving. Further, we will look into the utilization of motion tracking, for which purposes the motion tracking has been broadly utilized. That is, first use of the motion tracking is to stabilize the motion by utilizing the tracking data. Then add elements such as text or solids to a composition. Then insert 3D objects into 2D footage. Apply effects or color gradient techniques into the motion tracking. Replace screens on a TV, computer, or mobile devices utilizing the motion tracking. Because as the frame rate changes, with the help of motion tracking, like in which direction the motion will be, or predicting the next further location, the screen of the TV, computer, or mobile device can be replaced. Next kind of activity sensing that is being done is the activity recognition. That is, the majority of the works which are working towards the research problem are targeting towards the activity recognition. Activity recognition aims to recognize the actions and goals of one or more agents from the series of observation on the agents, actions, and the environmental conditions. This is applicable in case of medicine, human-computer interaction, or sociology. As you can see in the diagram, there can be many types of activities such as standing, walking, running, jogging, cycling, driving a car, or talking on a phone. All such activities, or sleeping or moving, all such activities are essential to categorize what is the state of the user and whether that state of the user is harmful or the user is in stress or not in stress. So such kind of prediction based mechanism are mainly relying on the activity recognition sensing. Next kind of sensing technique, sensing activity is the gesture recognition. Gesture recognition is the technology that uses the sensors to read and interpret the hand movements as commands. The gestures can be broadly of two types. One is the offline gestures. These gestures that are processed after the user interaction with the objects. For example, to activate a menu or to activate the mobile phone, we first need to press the button, and after that user interaction only the mobile phone gets activated. Or again, for example, there's a car which needs to be start, or a toy car which needs to be start after pressing the button. So that gesture will be provided, or making the action through the eyes, blinking action. Such kind of gestures are called offline gestures. What are the online gestures? These are the direct manipulation gestures. They are used to scale or rotate a tangible object. With the help of online gestures, the object keeps on moving and make a direction, or change the scale or rotate a tangible object. The applications of gesture recognition is in automotive sensor, consumer electronics sector, transition sector, gaming sector, to unlock smartphones, defense mechanisms, home automation, automated sign language translation. For example, in today's scenario, when we have the speaking bots such as the Google Siri or Amazon Echo, so if with the help of that, we can also make the home automation possible by asking the Amazon Echo Dot to Alexa or Echo Dot to just turn on the lights. So for that purpose also, there are multiple users. We have to make a gesture recognition technique in which the device can detect a certain gesture for a certain type of command. For example, to switch on the lights, we just have to blink the eyes. But to switch on the fan, we have to make a clap. So such kind of gestures are very relevant, are very important to be detected and sensed. And based on those gestures, the activities need to be performed. For example, you can see here also, there are many kinds of gestures with the help of which we can detect the kind of activity we want to perform. For example, the index finger shows a single one. The V sign shows the peace. Three sign shows the three. Three fingers pointed shows the three. Whenever a palm is open, that means to collect something. Whenever a palm is closed, that means to catch something. When there is a finger round with the thumb and the three fingers up, it symbolizes okay. The thumbs up symbolizes the thumbs up sign. Fist closes to make the action of punching somebody. The another action gesture is of swing, and this tick sign is a kind of sign of the smile. So with the help of such gestures, we can also, these gestures are also mainly used for the blind people to talk to each other, but at the to deaf people to talk to each other. But at the similar point, these gestures are now being automated to learn the actions of the people, and based on those actions, the activities can be performed. Next advantage or next sensing in the mobile sensing is the sensors fusion and augmented reality. Augmented reality involves overlaying the visual, auditory, or other sensory information onto the world in order to enhance one's user experience. Retailers and other companies can also use augmented reality to promote the products or services, launch novel marketing campaigns, and collect unique user data with the help of augmented reality and fusing the sensors. Unlike virtual reality, which creates its own cyber environment, augmented reality adds to the existing world as it is. In this part, various sensors are fused, and with the help of those sensors, augmented reality is possible. As you can see in the figure, we have the space in front of us. In the first figure, we have the empty space or a corner of the room in front of us, and we have the objects, for example, sofa, a chair, a table, in the application. And with the help of augmented reality, we can capture the space in the camera and place the objects accordingly in an image using augmented reality, which can sense the exact location, what are the parameters of the location, and based on then fit the objects onto the described location. In the next figure also, you can see there is a marketplace or a factory in which various products are placed. We want to detect the further the object which is placed at the further position and about how much distance that object is placed. So with the help of this augmented reality, it can measure the distance about what estimated distance that objects are placed. Thank you. This was all for the sensing activities which can be performed using the sensors and mobile sensing. And further, these activities are sensed and further processed for the computation process. Thank you.